Layer 3, the network layer. Network layer moves information between two hosts that are not physically connected. IP from the TCP/IP protocol suite is the most important protocol that operates at this layer. IP has two functions: addressing and management of fragmentation of packets. We may have more data than we can fit into a single data packet that I showed you. We may have data that's this big and the packet's only going to take this much. So it's going to take about 3 packets to be able to take this amount of data, right? Rough estimation. So that means we have to fragment the data. We have to chop it into fragment 1, fragment 2, and fragment 3. Fragment 1 goes in the first data box, fragment 2 in the second data box, fragment 3, third data box, and we send those packets on their way. Each packet has its own fragment offset or fragment ID. Fragment 1 of 3, fragment 2 of 3, fragment 3 of 3. When they get to where they're going, even if they get there in jumbled order, fragment 3 of 3 showed up first just because of random chance and congestion on the network. No big deal. The receive buffer on the other machine where we get all the packets in and kind of open them up and start processing them is going to read the data header. It's going to see the fragment ID and say, oh, you're 3 of 3. We need your buddies 1 and 2 before we can do anything with you. Why don't you sit over there for a minute? I'm going to put you in what's called this TCP sliding window. I'm going to put you in this nice little comfy chair. As soon as your buddies show up, we're going to drop them in there right next to you. And as soon as all of you are together, we're going to process you and move you on. And so those fragments get reassociated in order in the buffer on the other side of what's called the receive buffer. So IP takes care of that. Has fragmentation management capabilities. Also addressing is in your IP address. That's where we get it from. Layer 3 protocols can include RIP, version 1 and version 2, what we call RIP v1, v2, OSPF, Open Shortest Path First, v1, v2, and or, very common, very famous one we all know and love, ICMP, Internet Controlled Message Protocol. ICMP is the protocol that underlies what we commonly refer to as ping. When you go and you ping something, you're actually using ICMP as the carrier protocol to send out that request for connectivity verification and to return back that information. Routing Information Protocol, RIP, and OSPF are protocols that handle routing and are going to be able to manage the routing and the movement of data inside of our networks for us, depending on the kind of protocols we use and depending on the kind of data that we want to manage and kind of networks we're going to be setting up. We'll choose one or more of these protocols. One may be more appropriate than the other. One may be better for local area networks. One may be better for wide area networks. One may be dynamic. One may be not dynamic. There's different things that may tell us which one would or would not be appropriate, but ultimately they exist at layer 3. So we want to make sure we just associate them with layer 3 in terms of functionality. Layer 4, the transport layer. Transport layer creates an end-to-end transport connection between peer hosts. In other words, allows us to be able to understand how to transport information and manage it end-to-end, as we talked about, kind of like FedEx or UPS. At layer 5, the session layer, we talked about logical persistent connections being provided between hosts. We're setting up the rules of engagement, the rules of the game. Sessions analogous to a conversation, it says, and the session layer is responsible for creating, maintaining, and tearing down the session. It is responsible for structuring and managing how that conversation will take place. Layer 6, presentation layer. It provides services to ensure the peer applications use a common format to represent data. It's where we make things look pretty. It's like universal translation. We're going to take some data that comes in the structure of a data packet. We're going to run it up through the different layers. When we get up to the top here, right before we let you see it, we're going to make sure it looks, acts, and feels just like the data you're used to. And then by the time you see it in layer 7, in the application layer, this is where we're going to actually show it to you in whatever application you're using. It's going to look and feel like the data that you're used to seeing. This is what the OSI model is. This is how the OSI model is going to work. And these are the 7 layers that we've talked about and the functionality ascribed to each of them. Will be important for you to be familiar with them. As I said, it's important for you to understand how they work and what they are. It's also important for you to understand in order what the layers of the OSI model are so you can represent the model the right way. We'll have a little matching exercise for you a little bit later on to reinforce that. So I want to make sure you're familiar with that and give you a chance to review that as well. All right, so let's take a look. Talked about the matching activity, so let's go ahead and let's do that. You'll see here the OSI model. We have the different layers laid out. We're going to ask you to ascribe the functionality and match them up here. So I'm going to give you just a moment to kind of think through that and think through what each layer does. Network-related application programs, standardization of data present, physical characteristics, etc. You got to put in the appropriate layer name of the OSI model in order to match up the definition we have on the right. Going to give you a quiet moment to do that. As soon as you're done, think you got it all worked out. Let's come back, we'll take a look, put the answers up, and make sure that you have them correct. Let's take a look and see what it looks like, shall we? When we take a look, the graphic we had before, just to show it to you in a better way to be able to see it, you'll see that from the top we have the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and of course the physical layer, right? So we want to make sure that's going top to bottom from layer 7 to layer 1, that we know and understand what the functionality is as well as the order of those layers so we can interact with them. If you need a moment just to copy them down, make sure you got them correct, go ahead and take that moment right now. We're not in a rush, no big deal. As soon as you're sure you have everything organized and ready, we'll go ahead and we'll continue. We talked about, or I told you that we would talk about the TCP/IP reference model. Remember, the TCP/IP reference model is the DoD 4-layer model. You can see it on the right, the TCP/IP layer model. It has 4 layers: the application layer, transport layer, internet layer, and the network access layer. Those 4 layers are mapped over to the 7 layers of the OSI model. You could see that the application layer is going to represent, or be represented by in the OSI model, application, presentation, and session. Layers 7, 6, and 5 in the OSI model. Transport maps to transport, internet maps to network, network access in the TCP/IP layer model, the DoD model, maps to data link and physical. So we combine the 4 layers of the TCP/IP layer model into, or stretch them out and combine them into the 7 layers of the OSI model. Remember, the OSI model comes along a little bit later, is going to add some additional depth and carve out some additional sub-functionality within specific layers to further define what the TCP/IP layer or the DoD reference model initially laid out for us. We needed to add that complexity to better understand what was happening with our networking, and so this helps us to define and be able to do that.